Hello?
Hello, am I audible?
Yes. Hi. Sorry. Apologies for the delay.
No worries. So we'll be spending like initial 40-45 minutes on the coding problem and last
Okay.
10-15 minutes for feedback. So yeah, here's the question. Can you go through it?
Okay. Given an n by n matrix of distinct numbers, return all lucky numbers in the matrix in any order. A lucky number is an element of the matrix such that it is the minimum element in its row and the maximum element in its column. Okay. Um. Okay. So I'm just gonna read through the example just to make sure I understand. Okay. So so for this input, so a lucky number is an element of the matrix such that it is the minimum element in its row and the maximum in its column. Okay. So input 3, 7, 8, 9, 11, 13, 15, 16, 17. Okay, so in its column, 15 is the largest, and its row is the smallest. Okay, so it has to meet two conditions. Um, let me see. For example, 2, 1, 10, 4, 2, 9, 3, 8, 7, 15, 16, 17, and 12. Okay, so I'm looking for the smallest, and so from the first one, the smallest is 1. Second one, smallest is 3. And third one, the smallest is 12. Okay, so is 1 the largest in its column? No. Is 3 the largest in its column? No. Is is 12 the largest in its column? Yes. Okay. 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 Example 37, 8, 1, 2. So 1, 2. Okay. That's the smallest. And then, okay. Um, is it okay if I have like a minute just to gather my thoughts?
Sure, sure.
Okay. Mm, 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 mm.
I think yeah. Hello.
Okay, hello. Hello.
Yeah. So I think like this should work. What would the approach should work?
Okay.
What would be the complexity of that?
Um. So for getting the smallest in each row, I was thinking the way we could implement it was before. So just in the first for loop, when we're going through each list, we get them in. So that would be over n squared for that function. Before the getting the smallest, um, yeah, I'm thinking the time complexity would be over n squared.
Sure. Can you implement it?
Yeah. Okay, so fine. Oh, mm, what's that? Equals this. Hmm, hmm, hmm. Okay. Um. Okay. So first step, getting the smallest numbers. Okay. I want to say. I think the way we want. So getting the smallest numbers won't be a challenge. I'm just gonna think about how once we have the smallest numbers in each row, we go to checking if it's the largest in its column. So maybe in addition to storing the smallest in each row, I could store its column, and then I could go through the loop and just search for specific columns. Maybe I could
Mm-hmm.
search yes, maybe I could search each column and then
Mm-hmm.
have like the largest in each. Let me think about this for a second. So if I if okay, so if I store its column, I could do another pass and say um okay I could break apart whatever I stored and see if the largest. Okay, so yeah, so in addition to just storing this the value, I could also store its column, and then I'm thinking I do it like a second pass kind of thing, and where I like decompose each smallest value, and um I say if so like and now I'm looking so for uh now I'm basically looking at each column, like if this column is this, get the max. Okay, okay, so I could have a separate I could have a separate.
What is the issue with your the simple approach, like get the smallest in each row, then and also keep a track of column and see if it is maximum in that column.
Okay, I'll give it a shot and we make changes. Okay, so for I'll make two constants for Okay, okay, but and then for C, mm, mm, this is what I can do here. Okay. Okay. Since they're distinct integers, I could say, okay, what if I just did this for C in range was for, for in range rows for C in range columns if matrix uh, is in smallest. Um, so if it's in smallest, um, mm, let's see, or I could also just go through each column. I could get like the max. I could just get the max in each column since they're distinct integers. Um, I could just see if any of them that are in the smallest are also in the in the column with
Right.
max.
Right. Because yeah, they are distinct, so yeah.
Okay. So what I could do is I could just so this, mm, okay. Okay. So what I could do is I could just traverse over. So for C and range calls, um, then I'm gonna say the smallest row and then largest call equals to this. Let's call the append um, max of matrix. Yeah, see. Okay, and then I could say for mm, mm, let's see. Okay, yeah, you could add all those elements. Mm, okay, yeah. So okay, so for mm, okay, so for number, so for number in largest call, if num is in smallest, I should make this a set. To make this, I need to add set so that for time complexity sake. And then when I add it, I'll say dot add for if number is in smallest row, result dot add and result dot append num. And then we continue. We're just going through each of the values, the numbers in largest column, and then if it's in the smallest row, we'll append. Otherwise, we won't really do it. We won't do anything.
Sure.
And then return results.
Do you want to try running for one of the examples?
Okay. Um, Before I run it, could I go through just to make sure I don't make any typos?
Mm-hmm.
Okay. Okay. So lucky number 6 in the matrix. The result is initially empty. Smallest row is a set. Largest row is a list. Rows is just number of rows. Columns is the number of columns. And then for each row and rows, we're adding the minimum value in each row. Okay, alright, we're adding the minimum values. And then for each column, we're adding the max value. Okay, and then for number and largest column, if it's in the smallest row, we append it to the result. Okay, return result. Okay, okay, looks good. One. Oh, integer is not editable. Okay. Oh, let's see. Matrix here. Let's see. Max.
Oh yeah, this is just a column, right? You can't use like a row. You have to iterate through it.
Okay, okay. So I could, okay.
Unlike row,
So,
you have to iterate it, right?
okay, yeah, no, that's right. That's right. So I should just store the
You have
matrix
to.
manually. Okay, so I could say um, I can make largest column be the size of the rows. So I'm gonna make it initially -1 times len of calls for this row of calls. And then I'll just basically just store the maximum value um, at each index. Does that make sense? So I'll just traverse the arrange rows.
Do you want to traverse each column for each row or the other way around? Each row in that column.
Oh, okay. I could do that. I was just gonna. Yeah, that's probably a better way of doing it. I was just gonna say for each index, but like update the
Okay.
value. But no, I think that's a cleaner way to do it. In those. Okay. So okay. Um. Let's see. Okay, so what I'm gonna do is I'll do um. mm, okay. So what I'll do is I'll say actually I'll just like this for and for C and calls. What I'll do is I'll say largest call of C is equals to the max of um, um matrix of let's see. Maybe make it specific to each. mm, okay. Yeah, no, that makes sense. Putting it on top. So in each iteration, we're updating the specific um, column. Okay. And then yeah. So for each column, so initially, um, now initially the columns is of size columns, and for
So you're
each.
making an assumption that matrix is positive, right? But it's not
Oh,
negative.
that's true. That's true. So I'll make a negative infinity. Anything's gonna be greater than negative infinity, right? So this will go through hmm, each column for each. Okay, yeah. So for each row, it'll store the max, and then like for this example, it'll be goes 7. The largest. So initially, since so the length of columns is 2, so it's going to create two negative infinities values in the largest call, and then it's gonna go through 7. When it goes to 7, it's gonna store 7 since it's larger than. So now largest index of 0 will be 7. Then it goes through 1. 7 is the largest, and so it'll continue. Then it goes through 8, and then 8 is greatest, so it's going to store 7 and 8, and then so now we'll have 7 and 8 in our largest call array, and then if that number is in smallest row, then it'll append it and return results. Does that sound
Let's
good?
Yeah, let's try running this code. And just 15. Yeah, 15 is the right answer for this. Cool. I think yeah, that's good. Let's move to the second question.
Okay.
Yeah. So basically, it's another matrix problem. Like, given an n cross n binary matrix, you have to return the total number of special positions. And a position is special if it is the only matrix in that its only position with the value 1 in that row and that column.
I don't know. There's so many free space. Okay. Let me see.
Yeah, these
Given
are
an m
those.
by okay. Given an m by n binary matrix. Okay, so like zeros and ones.
Mhm.
Return the number of special positions in the matrix I and j in the matrix. Okay. Special positions. Okay. A position ij is called special if matrix ij is equal to 1 and
Mhm.
all the other elements in the row are zeros. Okay. So in the first example, 1 0 0 0 0 1 um 0 0 1 1 0 0 output to 1. Is that explanation 1 2 is a special position? Yeah, okay. In the row, okay. Okay, so 1 2 0 1. Okay, so 1. Okay, because for that row it's the only one, and for that
And
column
for
it's the
the
only
column
one.
also it's only 1.
Okay. And when we're supposed to return the number of them. Okay. Okay. For the second example, 1 0 0. So let me see. So in that row, So in that row it's only one, and in that column it's only one, and then for the second one in that row it's only one. Okay, okay, this sounds good. I think for this one my approach would be like traversing the matrix, and then if we reach a one,
Mm-hmm.
we want to see if we reach a one, we want to check its entire row and column.
Mm-hmm.
So then we'll call a depth first search function, and
Mm-hmm.
then that will check it for us. Like that, if we reach the base case, then we know if we reach the positive base case in the depth first search function, then we know that it's true, and so we'll have to increment maybe a global variable, and then we return the global variable.
I did not understand like what you mean by depth first search.
Um, so like so while we're while we're traversing the matrix,
Mm-hmm.
I guess like my idea, like my initial approach is if we encounter a one, we
Mm-hmm.
would we would call a depth first search function
Mm-hmm.
on that indice, and
Mm-hmm.
then that depth first search function will go through all of its rows and all of its columns. I mean, its entire row and its entire column. And if it
Mm-hmm.
doesn't encounter a one, then
Mm-hmm.
we increment.
Okay.
But if it
Okay.
does, then we don't.
Okay. Yeah,
Should I
I'm okay.
start putting?
What would be the complexity of that?
Sorry.
What would be the maximum complexity of this?
Um. So I think the time complexity of initially it'll just for traversing it'll be like O of n squared. But with the depth of search function, um, we're going to at most be traversing n by n as well. Again, n by n again.
Mm-hmm.
So we could be going all the way m all the, so m to n by n again. So I guess that would be like um in total like O of n to the power
Two.
4.
Right. Can you optimize it?
Yeah, let me see. Mm, let's see. Mm, 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 mm.
So,
Maybe.
like, you just
Oh,
need
sorry.
this information, like how many number of ones are in that particular column or that particular row, right?
Sorry, say that again?
You just need information like how many number of rows ones are in that particular row or that particular column.
Yeah,
Yeah. So can you pre-compute it?
that's true. Yeah. Let's see. So maybe what we could do is having it as um one. So storing an additional. Maybe if we could expand each row and have like an additional value. Let me think about this for a second. Okay. Okay. Yeah, I think so. Another approach I'm thinking of, it. I mean, based off what you told me, is um maybe for like each row and each column, we could let's see if we had so for the first one is one, second one is one, and the third one is one. Then for each column, and then I guess we could store a top left variable to, to look at like I said. Then this would be one, this would be one, and this would be one. Um, so since I guess like since I guess the max you could have is max possible is three. So let me see in this one over here we have we have um two 0, 1, and then we have 1, 1. mm, Okay, so that means this column can't have any. This one has 0, and then this one can have 1.
So like once
So,
you measure like number of ones in each column and each row, you can just iterate
mhm.
through the metrics and see each position, right? So rather than calling your DFS, now you know the answer in order of one times.
Sorry, can you say that again?
So your initial approach was going through each indices, and if it is one, call it
Uh huh.
DFS, right? Now
Uh
rather
huh.
than calling that DFS, can you use this pre-computed values?
Okay, so if I pass that into the DFS, then in the DFS I would know in
You
this
don't need
row.
to, you just don't need to know like whether this is the only one in this row and whether
Okay.
this is the only row in this column, right?
Okay. So, but if it's over 1, then we know that don't even check the column.
Yeah.
Okay. So okay. Okay. Uh, um. Yeah, I guess the first step would just be uh the pre-computations. Um. So I could pass. Okay. So I guess yeah, the first step is just generating the value. So I could store that in um. hmm, Okay. So rows and columns. Okay. I could just store um I could just make an array of rows or columns. Let me see. Okay, so define um lucky um special positions matrix. Okay, so I guess I could have um um call this row count and then call count. Now I'll just pass in the indexes. I'll just pass in the row count of I and the call count of I. Thinking when I send it to the TFS for I in range or C in range false. Um okay, so if if matrix uh, mm, mm, and we'll have a count over here. Result is equals to 0. Oh, first thing is pre-populating. Okay, so if then we want to up so so make this equals to um 0 0 times rows times rows. Matrix of RC is equals to 1. We want to increment the value. So row count of
Mm-hmm.
of R
Mm-hmm.
is 1. Call count uh, mm, equals to 1.
Mhm.
Okay. Then for R and range rows, range calls 1. Um, we want to call we want to call our DFS, but with the DFS um, we pass in R comma C, and we also pass in a row
You
count.
just Here you just need to check whether in that row and column, with the count is just one, right? So do you really need a
Oh, that's
position
true.
count? Yeah.
Um, but yeah, I think I'm putting that in one of the base
Mhm.
cases, but I guess that's also I could just say um if call count of SC equals to 1 and row count of R equals to 1. Hmm. Then result one. You can see so in this case it would be true. So they're both true, they're both true, they're both true. Okay, so but yeah, it shouldn't happen every time. I guess I could just check it for each. Yeah, so the maximum possible is like the number of rows, right? If they're different sizes,
It could be minimum of rows and columns, right?
or it could also be columns.
It
Okay,
could be minimum of rows and columns, right? The maximum possible.
okay, okay,
Yeah, let's try to run this for the example.
okay. What? One
Yeah, that's
minute.
correct. Yeah, 15 is from the previous one.
Okay,
So yeah, I think yeah, this works. So yeah, these are the other questions I had.
okay.
What would be the complexity of this second one?
The space complexity would be O of n
Mm-hmm.
since we're
Oh.
storing like a linear. There's gonna be two two linears, but asymptomatic that'd just be O of n.
Mm-hmm.
O of n space. Time complexity would be O of m and m by n since we're traversing each row and each column.
Cool. Awesome. I think, yeah, that makes sense. So looking at feedback, I think like only thing like you could have improved is like in the first question, you
Hmm.
somehow made an assumption that numbers are positive, right?
Yeah.
So yeah, so like do state out your assumptions and like don't make any assumptions like that.
Okay.
Apart from that, like I really like the way you came up with like n cross n approach for the first problem and even for the second problem. I think like
Okay.
you struggled a bit about you somehow there was an implementation error
Mhm.
while finding out the maximum in a column, right?
Mhm.
Um, so yeah, but like with help, you are able to rectify that. So it's good. I think yeah, I think like you need some implementation practice. Like my session would be like to practice a bit more about like matrix kind of a problem, because there
Okay.
was like in the first problem there was like little hiccups in implementation, but in the second
Mhm.
problem, like it was easy to follow. I
Okay.
like the naming conventions. You use right names for different variables and method. So
Okay.
yeah, I think like yeah, overall it would have been strong hire
Okay.
based on this improvement performance. So yeah, kudos for
Okay.
that. My
Okay.
suggestion would be like once you share the approach, right?
Mhm.
Try to discuss the complexity of that approach right away, like rather than
Okay.
waiting for interviewer to ask you the question, like what is the complexity, like share the
Okay.
approach and then
Okay.
analyze the complexity, because like you don't
Okay.
want to waste the time on some optimal problem, or you don't want to waste time in the
Yeah.
confusion.
Okay.
So yeah, that would be one suggestion I would say, like whenever you share the approach, followed
Mhm.
by the complexity.
Okay.
So yeah, so here is what I used to do when I was practicing. So on a link code or something, I used to create a comment section, and I
Mhm.
used to write down the clarification questions for problem, which
Okay.
I can think about, and then I will try to write down my approach in plain English words, right?
Mhm.
And follow
Mhm.
that with the complexity, so that I
Okay.
get in a habit of easily explaining or articulating my
Okay.
solution approach. Yeah. So I would suggest
Okay.
like if you can do it for for a while, you will
Okay.
get in that habit of doing that.
Okay. I appreciate that. I appreciate that. Thank you.
Cool. Awesome. Yeah. Do you have any question for me?
Um. Um. I guess. Was it one thing I'm always nervous about is like whenever I ask if I can have a minute or two to think about the question, like how is that? Because I always feel like I'm taking too much time, or like is that a bad sign, a negative
No,
signal?
that's not bad side. In fact, like we were able to complete both of the questions in 40 minutes. Like so,
Okay,
yeah. I don't think like you took much more time. Yeah.
okay,
Yeah,
that's
and that's a good catch. That's a clear communication. So yeah, rather than having an awkward silence, like
mhm,
sitting out like you're taking time to think about it. It's a
mhm,
good way to do it.
okay, okay, sounds good. Thank you so much.
Cool, awesome. Yeah, do you have any upcoming interviews?
Yes, I have a few interviews coming soon.
Oh, awesome, awesome. Yeah, and let me know how it went. Like all the best for
Okay,
your upcoming interviews. So yeah, I'm
okay.
really hopeful like you will do good in them also. Yeah.
Thank you. I appreciate it. Thank you.
Yeah. Have a nice day. Bye bye.
Take care. Bye bye.